Hi guys, welcome to our last example for 3.2. Now we have a formula for finding standard deviation when you're given a frequency table of grouped data. So this formula, we have the sum of our x values minus the mean squared multiplied by the frequency divided by the number of terms minus 1. So in this chart here, we have the age, range in years, and the number of shoplifters noticed or recorded. So they want us to estimate the mean age, sample variance, and sample standard deviation for the class. And 41 and over, use 45.5 as the class midpoint. So now instead of having actual x values, we only have frequencies of the number of times something happened within a certain range. So our x values in this problem are actually going to be our midpoints of the table. So first, for the classes 21 to 30, the frequency is 260 shoplifters. 31 to 40 had 348. And 41 and over had 287. So let's see what the sum for the total frequencies, 260 plus 348 plus 287 is 895. So now x for each of these is going to be the midpoint. So my first midpoint is 21 plus 30 divided by 2, which is 25.5. 31 plus 40 divided by 2, 35.5. And then they told us in the problem to go ahead and use 45.5 as the midpoint for 41 and over. So now x multiplied by the frequency, we're going to use that to help us figure out our mean. So let's see, we have 260 multiplied by 25.5, 6630. We have 348 multiplied by 35.5, 12,354. And then we have 287 multiplied by 45.5, 13,058.5. So let's find the sum of all those frequencies. 6630 plus 12354 plus 13058.5. So the sum of my frequencies times my x values is 3204 2.5. So now I'm going to use that over here to help me calculate my mean, which is equal to the sum of my x values multiplied by my frequencies, which is what I just found in the table above, divided by n, which is the sum of my frequencies, 895. So let's divide by 895. So my mean is about 35.8. So now that I have my mean, I can start to calculate my deviations, which is the difference between my x values and my mean. So here's my x values here, and my mean is 35.8. 25.5 minus 35.8 is negative 10.3. 35.5 minus 35.8 is negative 0.3, and 45.5 minus 35.8 is 9.7. So now I need to square each of these. 106.09. 0.09. 94.09. So now I'm going to take each of those and multiply by my frequency. So 106.9 multiplied by 260, oh, delete that, is 27794. Now I'm going to do 0.09 multiplied by the frequency, 348, 31.32. And then my last one, 94.09 multiplied by its frequency, 287, 27003.83. So let's sum those up. 27794 plus 31.32 plus 27003.83. And that's 54829.15. So now that I have that value, this is the sum of my deviation squared multiplied by the frequency. So S squared equals this value, 54829.15, divided by n minus 1, which is going to be 894, which is 61.33. And then my sample standard deviation is going to be the square root of my answer. Make sure you use your answer so that way you get the entire decimal. 7.831. So we could use Chebyshev's theorem to calculate the number or the minimum percentage of people who fall within specific standard deviations of this given mean age of shoplifters. So we'll try more sample problems like that in class tomorrow.